All right. Yep. So you'll probably get a practice quiz tomorrow. Actually, now that I think about it, I kind of forgot. So I'm guessing that's what'll be on the docket is practice quiz tomorrow. So you need to know how to do this though before you can do the practice quiz or the quiz for that matter. So today is what, 5/9? And we'll just like call this maybe two variable factoring. You shouldn't have any trouble with this. The only way you'll have trouble with this is if you already generally struggle with factoring. So my first example is this. And I don't think that this has popped up before. It probably is a little bit scary, right? Have you seen this before? You've seen this? Nice, good. So what happens in a case like this is basically a trick that I like to use is just basically take out the y's. And that, I mean, it's not really professional practice to do that, but if you allow yourself to not see the y's, then you can allow yourself to see that this is actually just a really ho-hum factoring problem. So if I gave you this little rinky-dink problem, then you would know that the answer is x plus 6 and x minus 10, right? Like that should happen by this point pretty quick. If I put y right here, though, and right here, then through the magic of placement, what happens is you force then the y back up here and the y squared back up here. So if you take a look like at these purple ones, what do those purple ones make? 6xy. And what do these green ones make? Right, so that's where you get your negative 4xy. That term comes to exist by placing y's at the tail ends. And then, of course, if you look at this red one right here, you get negative 60 y squared. So that's how the double variable stuff really works, is you just kind of take the second variable out of sight, out of mind, and deal with the problem like you normally would, and then strategically understand where the y's have to go back in. Right. But something like this, 2x squared y minus 20xy squared plus 48y cubed. What do you notice? Haven't heard it yet. Thank you. Yes. GCF, 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 GCF. Without this, this is going to be a real long couple of days. So always remember the GCF. So first thing I notice is that 2, 20, and 48 can all be divided by 2. What else do I see that they all have to offer? A single y. Good. So I'm going to rebuild now. What's going to be my first term? X squared. How about my second term? Nice. And then my back term? There you go. And this problem now really isn't very different than the last one, because now that we've gotten the GCF out, we recognize that as a pretty basic two variable factoring problem. So I'm not going to erase the y's like I did last time, but just in your mind, that's kind of what you think is, boy, if only those y's weren't there, then this would be pretty, well, it still is pretty light work, I think. So what are my signs going to be? Definitely a minus and a minus. And what magic numbers am I looking for? 6 and 4. So I need an x minus 6y and an, oops, I don't know why I didn't put x in that second one, and an x minus 4y. And then, of course, don't forget to bring down your GCF. Any questions on that? Okay. Next one I have for you is x squared y minus 10x y squared. And full disclosure, before we do this, this is a very unexciting problem. I just wanted you to be mentally prepared for the fact that, as you know, just because we're factoring doesn't always mean there's going to be like this glorious revelation, like, oh, I pulled out the GCF and there's a difference of squares, or there's this thing. Sometimes, as you'll see, the best we can do is just pull a factor and really, well, that was boring. So what can I get out of both of these? I can get xy. They both have at least one x to give me, and they both have at least one y to give me. They do not, though, share a number factor, so I'm not going to try to pull one out. What's left when I pull out xy? And that is it. So I just wanted to get one of those into the lecture so you can see that you're not doing something wrong if you don't feel like there's an end game. It's like, well, sometimes you just get what you get. So, any questions there? All right, next one. X to the fourth minus 9, x cubed y plus 20, x squared, y squared. What do we see first? Good. So let's, yeah. So x squared is definitely the commonality here. They all have at least xx. And so I'm going to pull out x squared and I'm going to rebuild. So what's my polynomial going to be now? And again, you see right away by now, this point in the lesson, you're like, I recognize this format. There's like all x's, blended term, all y's. That's that kind of flow of how the x's diminish and the y's grow. It's just a standard two variable factoring problem at this point. So my signs are going to be what? Minus, minus, and what are we looking for? Definitely 4y and 5y, and then don't forget to break down GCF. 4 down, 3 to go, still good? All right. Vandalizing my board there. Next one is 4x cubed y squared minus 81x y to the fourth. What do we do first? Definitely pull out y squared. What else can we pull out? Yeah, so let's pull them out alphabetically. I'm going to pull out a single x first, and I'm going to pull out double y's. So that's what your GCF should look like. And you rebuild. And what's going to be left inside? Done? What is that white thing? Very good. That's a difference of 2 squares, right? And we recognize that because it's 2x squared minus 9y squared. It fits the mold. And so it's going to factor down very simply, very cleanly, I hope you agree, into square root plus square root times square root minus square root, and then drop your GCF. Done. 5 down, 2 to go. Everybody still good? I don't remember what my inspiration was for these last couple, but I purposely wrote all 7 of these, so I'm just going to ride this out and assume that they have purposes. I was watching the Lakers and Warriors game when I was writing these, but something caught my eye and thought, oh, I need that in my notes. So 2 more. So this one is x cubed. Yeah, I don't even know what this one seems pretty bland. What do we do first? Pull out that GCF, and what is it? X. Excellent answer. There is no y. No, the first term doesn't have any y, so we just can only get the x. And that leaves behind what? Again, fits the perfect mold of all x's, blended term, all y's. That should be pretty familiar. So it's going to factor just like a normal quadratic trinomial, right? What are my signs going to be? One of each. Good. So I need an x plus and I need an x minus. And what are we looking for number-wise? Positive 8 and minus 2. Good job, you guys. And then pull down the GCF. I think my only inspiration for that one was that I wanted to get back to doing one of each sign, one positive, one negative. I don't know. This last one is a good one though. I thought I would not like this. Generally, if it's a problem that I would not like to do, that probably means I should put it in the notes because we can get in the way of trouble, I hope. So ideally, we're hoping you should know by now that when you look at the problem, you're hoping it comes out as a difference of squares or maybe a difference of cubes, something like that, right? That's going to be our only hope for like multi-step. But before we even begin, what do we do? Yeah, and do you know by chance what it is? Okay, let's start with the obvious part, and that is I agree with you that that's obvious. Each one has at least x to the third, and each one has at least y squared. The hard part generally is figuring out what's the best I can do with 12 and 588. You do? So I can divide them both by 12? Yeah. Perfection. Bless you. So I'm going to pull a 12, and I'm going to pull out all my x's that I can and all my y's that I can, and then I'm going to rebuild and hope for the best. So what's left over for the first term? Nice. And what's left over for the second term? There you go. And does that fit the mold of a difference of two squares? Yeah. It does. Good. So I tried to just hide that one from you a little bit more, but at the end, like I've told you before, there's always going to be like a core problem that I want you to do. I just layer it with fluff. The fluff, of course, just being the GCF. So when I factor this down, it factors into just the typical plus and minus pattern. So x plus, x minus, and what goes after those? Yeah, you guys are too good. And then don't forget to drop down your GCF. So that's what today's worksheet is just 12 practice problems on this. And then I say tomorrow you'll have a practice quiz. I'm 99% sure that's what will be tomorrow. And then Thursday, when I'm back in class, we can go over that and answer any questions. And then we'll quiz next week. Most of us. When's your last day, seniors? Oh, so you'll still be here. All right.